Okay, yesterday we talked about copy constructor. We said that there is always a copy constructor defined for your class. If you don't define it, like the assignment operators, copy constructor is defined, and its default behavior is it gets the other objects and it makes a member-wise copy, like the assignment operator. Okay, it makes a member-wise copy. If this behavior is okay for you, then the default copy constructor should be fine. Don't define anything, any copy constructors. If it is not okay, then you have to implement your own copy constructor. The same is true with the assignment operators. Okay, up to now, since we did not need any deep copies of our objects. What's a deep copy? Deep copy is this. Okay, deep copy is this. This is shallow copy. Remember yesterday? If I make this copy, D1 to D2, copying elements one by one, A to A, capacity to capacity, use to use, okay? This is shallow copy. This doesn't follow the pointers and copy the pointed places, okay? This is shallow copy, and this is deep copy. Deep copy follows the pointers. It says that, okay, this pointer is meaningful. It is showing me some data. I am going to copy that data too. So it copies this data to this place. Okay, so this is shallow and this is deep. So usually your copy constructor and assignment operator is needed whenever you need to do this kind of deep copy. Okay, for the money class you don't need the deep copy, because all you need to copy is the dollars part and the cents part, right? That's it. So two integer assignments are okay, but for this class PFRAD you need deep copy. Question for you. In your homework, you have been using the vector class as your data member, right? So do you need deep copy or shallow copy? You have a vector in your objects, right, in your class. And the vector is something dynamic. So in your class of solitaire peg, or what do you call it? Okay, so peg solitaire. Do you need a shallow copy or deep copy? Well, you have been writing your homework without any issues, I guess. So it seems like shallow copy should be enough. So it should be shallow, right? Yours should be shallow. Yeah, the answer is shallow. But why? What is the meaning of copy constructor, default copy constructor? It makes a copy of each element one by one, okay? And it uses the copy constructor of those elements. So if I have an integer, copy constructor of integer is just takes an integer and copies it. Copy constructor of other integer is this one. Copy constructor of integer pointer is just copying the pointer itself. Copy constructor of a vector is the proper thing. It just copies, makes a new copy of the vector, okay? So they handled it. So if you have a vector or any properly written class as a member of your class, then you should be fine with the copy constructor, default copy constructor, okay? So because, I mean, the default meaning of the member-wise copy will work for the vectors, because we have been doing the vector assignments, no problems, right? It works. So if you have a vector as a data member, if you are doing composition like that, you should be fine. You should be fine. Don't write the copy constructor. So we wrote our copy constructor actually. Here is our copy constructor. Here is, how come this one doesn't say the, every time I have to load it? I think it was 10, 12, which one? Let me load them all. Yeah, I guess that's it, because I made some changes. Yeah, here are my changes. So let's look at the copy constructor again. So the copy constructor is a constructor actually, and it uses the member initialization syntax, and it says that I am going to copy the capacity and the number used fields first, and then I am going to make a new array which will be exactly the same capacity as the other array, other PF array, and I am going to do this one by one. Okay, let's not go into fancy stuff. Let me just do this A I and other I, or maybe do this dot AI. So I should be fine with this copy constructor. Oh, okay, it is already there. Sorry. Okay. So any questions about the copy constructor? So we talked about why this is a const, why this is a ampersand. Previously we said that it is better for you to accept your parameters as a reference just to avoid this copying, right? And make it a const so that you get the compiler help in case you modify something, etc. In this case, yeah, these are still valid, but without the ampersand, you have a very serious problem with infinite recursion when you are doing the copy construction. Okay, if you don't put the const, there is no way that if you don't put the const here, okay, keyword const, there is no way that you can make a call by value of const PFRAD objects. Good. So add element, let's do this. Add element is very simple actually. If the number of used elements inside my PFRAD is larger than capacity or equal to capacity, then I just terminate my program. Okay. So because I am saying that at the beginning you told me that your capacity will be this much, and now you are trying to add more elements to this array, I can't do that. Okay. Otherwise, if I have enough space, I put element to the position used, and then I increment the value used by 1. Okay, good. Question for you. Is this, no, well, that's not a good question actually. Okay, I will say that question, maybe I will come back to that later. Okay. So this is add element, and this one is not doing any reallocation stuff. We will, in a few minutes, maybe we are going to write our own add element, which will not be limited by this capacity. It will be limited by the available memory only, but I'm going to do it in a few minutes later. So the index operator, it's just const index operator and non-const index operator, they are exactly the same. No problems here. And the assignment operator, let's look at this assignment operator. Let me get rid of this one. So, and let me get rid of, what is this now? Okay. Okay, so the assignment operator says that, okay, the right side, okay, right hand side is the other parameter. Okay, I am going to assign whatever is passed to me to myself. What do we have in the other one? I have the capacity, I have the used, and I have the dynamic pointer A. Okay, so this is what I am doing the first. Okay, this is kind of smart to check if my capacity is not the same as the right side capacity, because if my capacity is the same, then I don't have to allocate anything, right? If my capacity is the same, I don't have to delete anything, I don't have to reallocate anything. So if the capacities are same, all I am doing is this. I do this right side capacity to capacity assignment, used to used assignment, and then in a nice for loop, it's like the copy constructor. Get all the elements from the other array to my array now. Okay, and I'm returning myself as a reference. I am returning myself as a reference so that I can do this cascaded assignment thing. So A assignment, B assignment, C assignment, D, etc. Okay, so this is for the cascade stuff. I am returning a reference to myself. Okay, good. So that's the thing. If the capacities are not the same, then I am deleting my array A because I don't need it anymore. I need to allocate something new. Okay, so I am going to get a new array on the heap. Okay, new double right side capacity, and I will assign it to A. And that's going to be it. Okay, so this is my assignment operator. It looks like this part is very similar to the copy constructor, right? This part is very similar to copy constructor. Let's go to the copy constructor. Oh, I can do this, right? Let me turn off this irrelevant stuff here. And that element, let's get rid of that one. This one, and why don't I copy this here? Okay, let's compare those. So this part, okay, and this part is the same. And I copied get number used to used and get capacity to capacity. That's what I did here. And at the beginning I have this. Okay, says that if my capacity is not the same. How come I don't do the same thing in the copy constructor? Let me try to fit that into the same, yeah, okay. How come I don't do this section of code in my copy constructor? How come I am not deleting anything, okay? How come I am not saying that if my capacity is the same as the other capacity, don't do anything, right? Line 166 is just directly just make a new array, double array. It doesn't check, it doesn't delete anything.
In copy constructor, I guess other is uninitialized, so
What do you mean other is initialized, of course.
We will copy
Other initialized, otherwise how am I going to make a copy? Just go on, don't stop. Other initialized, I mean other is a valid object. Otherwise, there would be a very serious problem.
capacity of other
Yeah,
is
it is initialized. No, see, this is the copy constructor. Capacity of other is initialized, and it is a nice value, and I get that value to my capacity. No problem there. But you have a point. You in your sentence you are using the wrong object name.
Yes, not others, but the one we will.
Okay, myself. You're talking about myself, yourself. Okay. So in copy constructor, he says that in copy constructor, the other is a very nice, fine object, no problem. But I am a new object of this PFArray class, right? I am a new object. I am not initialized. I did not initialize myself with anything. My capacity is wrong, okay? It is a garbage value. My use is a garbage value. Most importantly, my pointer A is not a valid value. It doesn't hold anything meaningful, okay? It doesn't point to anywhere. So I cannot delete A. If I do this, if I do this here before doing that, okay, that would produce me a nice segmentation fault or something else, I don't know. That would be a bad thing because what am I deleting on a new object? I mean, this object has just been formed in the on the heap by the compiler, right? It was not initialized yet, so the A doesn't hold a meaningful value, and I'm trying to delete whatever A is pointing to. Usually it is 0 by coincidence, okay? If you try to delete at address 0, then you are going to get a segmentation fault. So that's a bad thing. So that's the difference, kind of difference. If you like to compare these two functions, the operator overload of assignment, okay, and the copy constructor. Copy constructor doesn't have to take care of what I have been doing, what I am pointing to, okay, because I am not pointing to anything with the copy constructor yet. But with the assignment operator, I am an alive object, I am a valid object, I am pointing to something. First, I need to take care of that part, okay? If my capacity is not the same as the right side capacity, then I need to delete my place, and I need to do this. Okay, good. So that's the copy constructor. What else? Yeah, we have never written this destructor thing. Destructor is very important. Why important? Because if I have an object, if my memory picture is like this, okay, whenever D1 is deleted, compiler will take care of this A, cap, and used, no problem. But who's going to take care of this part? Okay, I need to take care of this part. I need to delete this part. I need to delete the place that is pointed by A, and after that the compiler can take off these three, one double and two integers. Okay, so before my object dies, I have to do this deallocation of the memory. Usually we use constructors for those kind of stuff. What did I say? I said constructors and the destructors are kind of the opposite of each other. Well, maybe that's not a perfect term to use, the opposite of each other, but constructors are called when the object is first created to initialize the object, okay, to allocate space and etc. Destructors are called to do whatever needs to be done before the object dies, okay. So usually with the destructors, if you have some dynamically allocated space for your object, then you call your destructor, and the destructor will take care of your dynamically allocated space, and that would be it. That's why I have this simple line of delete A. Remember, deletes the array, and when we say this parentheses or the square brackets, it says that I am deleting an array. Okay. What did we say before? Are we okay? Do you guys hear me okay, online people? Is my voice breaking up again? Anybody hearing me? No? Are they talking? What? They say okay, okay. Okay, so if my voice breaks up, just let me know. So this square bracket means that I am deleting an array. Actually, the square bracket means that I am deleting an array. Please call the destructors of each element. Okay, that's the meaning of it. So delete A already gives the memory that is allocated for A. Okay, so it already returns the memory allocated. There is no problem with the delete A, but when you put the square brackets, it means that I am deleting an array, so there are a number of objects in this array. Call the destructor of each element one by one. That's the meaning of it. That's why you need to put these square brackets. Just test this, okay? Write this program and delete this array without the square brackets, and delete the array without the with the square brackets, and put a single line there in the destructor of this, whatever the array of A is. In this case, it's a double, so you can't do it, but do it with some other kind of array, and you will see the difference. Okay. By the way, that's a very good experiment to put stuff like here, saying that, okay, see out, this is Destructor, okay, and then you copy see out here, this is copy constructor, and similarly see out assignment and see out constructor, etc. So run some programs and to see what's going on, and make a call by value, make a recursive call with this object, and make an object of this class using the new operator, etc. See what is, when is, which functions are called at what time, and that will make you understand things a lot better. Okay, so do we have another functions? No, we don't have another functions to talk about this class. Very small primitive class that doesn't do much. We call it, it's a dynamic array, okay, PFArray, dynamic array, but it doesn't, by adding more element, it doesn't increase its capacity. All it does is that it uses up to the capacity. It's kind of a dynamic. And let me go back to the slides and see if I am, yeah. So we talk about this copy constructor, okay. We talked about the three cases, and it behaves like the assignment operator, and yeah, okay, good. So these three stuff, okay, these three stuff, copy constructor, assignment operator, and destructor, okay, these three stuff are called big three. Okay, big three functions. Why do we call them big three? Because they are important. If you need to implement, okay, if you need to implement some kind of a memory allocation, deep copying, and that kind of stuff, you need to implement this big three. Usually big three is implemented when there is a pointer involved in your class, okay. You are doing some memory allocation, so in your destructor you have to deallocate it. When you are assigning objects, you have to allocate space for your left hand side, etc. Okay, these are called big three, and they are important, and it is your responsibility to make a decision as a class designer, class implementer. It is your responsibility to make a decision whether you need the big three or not. Usually if one of them is needed, let's say you determine that you need the copy constructor for some reason, and 99% of the cases, if copy constructor is needed, assignment and destructor is needed too. Okay, so they usually go together. And in your class, if big three is not needed, okay, in your class you usually write stuff like, let me try to open one class that doesn't need the big three. Chapter 7, nobody knows. Chapter 8, what was chapter 8? I forgot, but I am sure. Okay, money. So usually you put a comment like big three is not needed. You put this comment so that your customer knows that you did not forget about big three. You know about the big three. You did not implement it on purpose. Okay, you did not implement it on purpose. It's like, remember our constructor that doesn't take any parameters? We used to say intentionally left empty, something like that. Okay, either you implement the big three, or if you don't implement it, you put this comment in your class header: big three is not needed. Very important detail here, because if big tree is needed and if you don't provide it, okay, your class is a buggy class. Why? Because call by value will not work with the copy constructor, right? Call by value will not work, because if the big tree is not is needed but you didn't implement it, your default copy constructor does a shallow copy. Your default assignment operator does a shallow copy, but you need what? You need a deep copy for your assignment operator and the copy constructor. Okay, so your code will compile. It looks like it's running, and sometimes it will run. But whenever you do assignment, your assignment will be wrong. Okay, because you will end up sharing same parts of the memory. Whenever you do copying with the call by value or returning an object from a function, you will be in trouble. Okay, so big three is important. Always when you design your classes, some of the rules, okay, always try to make everything private. Try to make everything private. If it doesn't work, then you have to say, no, I cannot make this private because get amount is needed by customer. I cannot make it private. So make them, in that case, public. Try to make everything constant, including all the parameters and the functions. But sometimes you can't make some of the things constant. For example, constant constructor doesn't make any sense. So I don't make them constant. Or set dollars doesn't work with the constant. Okay, that's the other thing. And then you think back and you talk about big three. Do I need the big three in this case? Well, I mean, shallow copy will work fine with these two integers, so no problem. So you put this comment in here. Okay, big three is not needed, and you don't implement them. If it is needed, you implement them and you put it in there. Big three is needed. Okay. So that was the program. Let me go back to this one. PFRA. Let's remember what did we say. Let's work on this add element stuff. Add element. It says that its capacity is large. Its use is larger than capacity. I don't like this one. I will just copy paste this, comment this out, and okay. I am not going to do this anymore. I am going to do something else. If use is greater than capacity, what am I going to do? So let's draw the picture actually. Okay. This is my object D. I have three data members in it. Okay, and I have 10 doubles. Let's say my A is pointing to this. My used is 10 and my capacity is 10. Okay, and somebody says that D dot add element 3.5. And my code is running now. My code is running, and okay, my code is running. What is this doing? What? Okay, get rid of this part. My code is running and my picture is like that, and I came to this one. Use is greater than equal to capacity. Yeah. So what should I do? I know that I need an if space, right? I need an if space. 10 is not big enough for me, so I need to allocate some space. Okay, do this. A new double and what? Let's say capacity times 2. Good. So I did something like that. Now my A is pointing to some new space. Its size is 20 now. Okay. Good. What am I going to do now? So write a for loop. Write a for loop for I, integer I is from 0 to I less than what?
Used.
Capacity. Used and capacity are the same, or used doesn't matter. Okay. And plus I, right? So copy the contents of this one to this one. So what did I do? A I guess the value of what? AI?
We need to use a temporary pointer.
Yeah, I did. I think some. Well, maybe I should do this. Yeah, maybe you're right. Yeah. So yeah, maybe I should say double star T. Okay. Now I will say this is not like that anymore. Okay, this is like this, and I have somewhere in my memory a double T pointer, and this pointing to this location, right? So Ti with the will get the values of AI. Okay, so see the mistake that I did? I forgot to make a backup of A, because if I lose A, nobody will remember my old location, right? So I am keeping this temporary T so that it remembers my old position. Okay, so after that, I should be fine, right? So I should maybe now get rid of this place and do it here, right? So how am I gonna do that? I will just say A guess the value of T. That's it, right? So the picture is like that, and then oh, we forget about the capacity. Let's be at the beginning. Let's do this. Capacity should be times assignment 2, right? I change the value of capacity. I multiply it by 2. My capacity is my 2 times now, and I copied the elements from the old location to the new location. My capacity is now 2 times. What do I do now? And I can put this A used element into this position and increment used by 1. So what's going to happen? So whatever I have here, 1, 2, 3, 4, 5, whatever I copied them, 3, 4, 5, up to now, and new element is added here. New element is added here. Okay. Is this okay now?
Don't you have to change the used and the for loop, the Boolean expression?
Don't we have to change the used?
Yes, in the for loop.
Well, used is changed here, used plus plus.
But now used isn't changing capacity is 2 times its formula.
No, well, I mean, my use was 10, okay, but I didn't have that many elements in there, right? So I incremented I increased my capacity by 2 times, so I have 20 available positions, and the 10th position is available for me now. A used is element, and I incremented used by 1, and used is 11 now.
I mean in the for loop.
In what? In for loop?
Yes, the used shouldn't it be capacity instead of used, or
For loop will run from 0 to 10. 10 will not be included, of course. And you don't have to change use. I mean, you use. I mean, at the end of this add element, use will be incremented by 1 only, okay? If it was like 10, it's going to be 11. If it is 12, 13, it's going to be 14. Okay? Capacity, it depends. Capacity sometimes changes, sometimes doesn't change. In this case, capacity will change, okay? Whenever use and capacity is the same, they are equal, okay? Otherwise, capacity will stay the same. But use is always incremented, will be incremented by 1. Okay, any other problems with this function? Yeah.
Should we delete A before assignment?
Yeah, maybe we should. Maybe that's a good idea. Don't we have to delete this A? I mean the old version of it, because if we don't delete this place, it's going to be a what?
Leak.
Memory leak, right? So we have to delete it. Let's delete it. Delete T. Right? No, that's bad. Delete A.
Before.
Well, that's bad too. Why? Because if I delete afterwards, then I'm deleting whatever I got already. So delete A is good. So the picture is still the same, didn't change. This place is not mine anymore. I cannot reach it. And in fact, by doing this, I will forget that address too. Okay. Remember, the book said that sometimes after deleting A, sometimes maybe you should this from time to time. Okay. Now PTR. Well, in that case, I don't have to do that because line 130 is going to do this anyway. So it's going to change its value. So I am going to take this out. I don't need to assign 2 times. Okay, so this PFRAD is a more dynamic array from now on. It doesn't say that I am out of place. I'm filled in. I filled in all of my capacity. So this one, as long as this T is not a null value, okay. Remember, if T is null, what does that mean? It means that I am out of memory. As long as I am not out of memory, this code should be fine. It will work fine. Okay?
So,
Yes?
on line 128, don't we need to use index operator?
Sure. Yeah. If I can find this, yeah.
Also, I have another one. So, is index operator overloaded for this deleting operation?
No. Actually, delete and delete square brackets are 2 different operators. Okay? So they are 2 different operators. And new and delete, they can be overloaded, but don't do that. Okay? So some of these mistakes, I am doing that on purpose. Some of them I really make those mistakes. Okay, I for example, square bracket I just forgot. Okay. Any other questions? So, well, I mean, this is really like vector. Okay, vector class. Okay, what is the biggest difference between this class and the vector class? In terms of its usage as a customer, what is the difference? Biggest difference? Let's go to the main. Where is my main? Where is okay, here it is. I have my PFRAD. Okay, here temp. I keep adding elements instead of pushback. I have add elements, and I can get the size. I can get the capacity if I like to. What is the biggest difference between
A vector's base type can be anything.
Yeah, vector could be a vector of integers, doubles, characters. This is just a vector of doubles, right? This is just an array of doubles. So how to do that? How to make a array of type anything that you like? We will talk about it. It's called templates. This is not a templated class. Vector is a templated class, and we will learn how to do that. It's very simple actually. It's just 2-3 lines of modification. That's it. Okay. What else? What do you like about the vectors that you like to add to this class? We have pushback.
Resize.
What?
Resize.
Resize? What do you want to do with the resize? Just double the capacity, change it? What is the definition of resize? We can do that maybe. So resize changes the capacity, right? So if the new size is smaller than the old one, you just ignore the rest, right? That would be it, I guess. If it is larger, then we are going to allocate some new spice, and that, I guess that's it. We can implement it, but let's implement something more interesting. I mean, interesting. Well, it's interesting for you, but more interesting for me. How about this pop back? What does the pop back do?
Remove the last.
Okay, STL vector pop back. Pop back is just will give you the last element and it will just remove it from the vector, right? Is that correct? What? Yeah, I am not connected to the internet. These guys are hearing me. I hope. I am trying to get to the exact header definition of the pop back. Is it returning a reference? I don't think it's it just returns a. Okay, it returns a. Do you guys hear me? Are you getting my picture, online people? Do you think they hear me?
Yes, we can.
Oh, okay. Oh, okay. So I got it. I don't know what's going on. So pop back is void. Yeah, it is just void. So it just deletes the last element. So let's implement this one. And let's implement this inside my class. Void pop back. I'm going to do it this way. Is this a const?
No.
No, because I'm going to modify it, right? So it just doesn't return anything. It will just do what? It will just, it is as simple as this, right? Unless I don't have an element. So maybe I should say used is larger than 0. In this case, decremented. Otherwise, what am I going to do now? Otherwise, do nothing. Maybe if is a better alternative here, because I don't have anything here. Okay. If used is this much, then decrement used by 1. Okay, so this is as simple as doing that. Remember, I didn't put anything at that last position, right? So I just decremented used by 1. And in fact, the book does the same thing. If the empty, when you say empty array, it doesn't delete anything. It doesn't modify anything other than use 0, right? Okay. What else? What else? Let's go to the vector class. Choose something inside this vector. Vector is here, okay? Okay, let's go. Okay, size, resize, change size, capacity, empty, reserve. Okay, request a change in the capacity. Change it. Okay, at. So at is the same as index operator, but if you are not within the allowable index, then it's going to give you an error message. Okay, insert. So okay, why don't I give you these as as assignments. Okay, just implement this insert, erase, swap, clear, and etc. So you would know. There is no assignment equal to, okay, less than, greater than, because for the vectors it doesn't make much sense for the general vectors, but maybe for the double vectors you can do that, right? Maybe for the double vectors you can do that, because double vectors are very useful to do like vector arithmetic, right? What is the, maybe I could do stuff like this. If this is my vector 1, 2.1, 5.0, dot, dot, dot, 7.2. Let's say this is 10-dimensional vector, and this is my vector 2, okay, and 5.1, etc., 7.21. Again, 10-dimensional vector. Maybe I can do v1 dot v2 dot product. Okay, what does this produce as a type? If I do the dot product between these two vectors,
Integer. Double.
no, it will produce a double. It will produce a scalar, right? Because it's a dot product between two vectors. How about this one? v1 cross product v2.
Another vector.
It will produce another vector. So maybe you could implement these for the PFRAD. But what happens if their sizes do not match? Then in that case, you will say, okay, I can't do that. Maybe I will terminate the program or do something else. Okay? Or you could make a comparison between v1 and v2. Or what kind of other things we can do with the vector? Well, you took linear algebra, right? Did you take linear algebra yet?
Next
No?
semester.
Next semester, okay. So matrices and the vectors are always interesting for all kinds of fields of engineering, including the computer science. And maybe you can make this library a little bit larger so that it does that kind of stuff. So let me go back a little bit and let's talk about whatever I have skipped. But before that, maybe I need to take some break. Let's be here around 10:35. Okay? Break. Toplama nerede ya? Hiç sonraki ne zaman geldin?
Yani 15 dakika kaldı. Hocam son 4 kişinin ismi yok da ben
Ha?
yazmıştım ismini. Son 4 kişi yok, 41 kişi var. 41.
Nereye gidiyor onlar anlamıyorum ki ben ya.
Ha yazmışlar ismini, ben yazmadım. Aynen benim ismim sen.
Ha?
Listedeki en son.
Tamam sana.
Efendim?
Birden fazla constructor tanımlayabiliyoruz ya bir class için.
Evet.
Evet. Birden fazla destructor tanımlamak söz konusu mu?
Değil, yok. Çünkü constructor'ları sen çağırmıyorsun, otomatik çağırıyoruz ama hala kontrol ediyoruz. Diyoruz ki tek parametreli, iki parametreli, üç parametreli.
Öyle mi?
Tamam mı? Destructor'ın öyle bir durumu yok. Ölmesi gerektiği zaman compiler otomatik öldürüyor onu. Dolayısıyla ona parametre gönderemezsin.
Peki
Parametre gönderemezsen de signature'ı farklı olamaz. O zaman birden
Peki,
fazla destructor yazamazsın.
Constructor'ları da hani normalde biz çağırmıyorduk ama hani isteyerek çağırabiliyoruz ya. Explicit code falan yapabiliyoruz ya da
Destructor'da da öyle bir şey yok, hayır.
istesek de çağıramıyoruz bu şekilde değil mi?
Belki çağırıyorsundur ama ya o öyle bir şey yapma. Çünkü obje ölmeden gömersen eğer başın belaya girer. Tamam, çünkü compiler'ın
Aslında
üzerine
şey-
destructor'ı bir daha çağıracak.
Aslında şey diye düşünmüştüm çünkü biz hani yazdığımız Destructor'da sadece o hani A pointer'ının işaret ettiği o ilk memoriyi siliyorduk ya.
Evet.
Diğer
Biz sadece salı geliyorduk. İşçi günü herhalde. Ne bileyim. Her kadar salıcı mesela kadar yoğun değildir bence. Gene İstanbul'da yaşıyor. Ha? 11 Müslüman öyle bir şey. Annem Müslüman öyle. Gene İstanbul'da kurmaya çıktık. Metrisler herkes takmış durumda ilerler. Hoca da taklar. Nereye gitsin kimse? Şu an öyleyim aslında. Bugün şey yapacağım ben. Çizgilerini şey yapmak biraz düşünmüşüm. 7 soru falan yapıyorum. Ben hayır tamamen ödeyişli olur. Şurayı bulmak istiyorum. Belki de bugün işte şey o Constructor da şey yapar diye düşünüyorum. Ondan sonra şey sonucumuz ne var? Halledeceğim. Allah'ım çünkü bari yan bakmıyor. Çünkü her şey yapacağım. O yüzden direkt 12 can burada. Ben uçmuşum. Dövbe çalışamıyorum. Ben de hallettim. Full kitap böyle oda var. Oda boş bir yere gittiydik, tamam mı? Ben direkt döndüm, oda doldu herhalde. Boşuna söyledim. Şu an adam bu oda boştu. Çok şaşırdım. Bir de bulduğumuz oda konteyni taksın. Kaç kişilik tatlıydı? Ben de yedim.
Okay, so maybe I should put quotations opposite of constructors. I mean, no function is an opposite of the other. It is kind of the whatever you are doing with the constructors, you are doing the corresponding part at the end of the lifetime of an object. Of course, when you initialize something, you don't de-initialize anything, right? I mean, just leave them as they are. But if you need to deallocate some memory, then you have to deallocate it. Okay, I had a question. Somebody asked me, what happens okay, when I delete this PFRAD object? Okay, all I do is just delete this array, right? What happens to this A, used, and cap? who deletes them. Okay, they are deleted automatically by their destructors. Okay, doubles destructor doesn't do anything, integer destructor doesn't do anything, and caps destructor doesn't do anything. It would be a stupid thing to do, but let me do this stupid thing anyway. Let me put a money object in this class. Okay, I have now a fourth data member in my class, and what am I going to do with this money object when I write this destructor? I am not going to do anything because money will be destructed automatically. Okay, because after this destructor is run, all the destructors of A, use, capacity, and money M will be called automatically, and they all will be destructed. Okay, just try this. Add this money inside this class and write the destructor for the money, which will include just a simple cout statement. Okay, and see when are they called and what they are printing on the screen, and you will see that all the destructors are called. Okay, no object is going to die without calling its destructor. If you define your own destructor, your destructor will be called. Otherwise, their default destructors will be called. Okay, and that behavior, that default behavior of the destructor is okay for you, then you don't overload them, you don't define them, you don't implement them. Otherwise, you implement them, including the other two elements of the big three. Okay, so let's go back, and we talked about the destructors, automatically called when the object is out of scope, when it dies, okay, or when you delete an object on the heap. And default version only removes ordinary variables, not dynamic variables. And that's why we have to delete our array A in our destructor. Okay, dynamically allocate variables, usually they don't go away. They have to be deleted. That's why we have the destructor, and we talk about this. And shallow and deep copies, very important concept actually. The default copy constructor, default assignment operator, they do shallow copies. What does that mean? They just copy the elements one by one, member-wise copy. Okay, assignment copy is only the member variable contents over. Deep copy, okay, is needed with the pointers, dynamic memory whenever they are involved. And when we are doing the deep copy, one thing is important: make space for our data, large enough space for our data, then run a loop to copy our content, and don't forget about deallocating our old space. For the copy constructor, we don't have an old space. That's why in copy constructor you don't see anything like a destructor or delete operator. See, this is my copy constructor. Where is my copy constructor? Yeah. Inside my copy constructor, I don't see anything like a delete. Okay, although I am doing the deep copy, I don't see anything delete because there is nothing to delete. My object is being just right now formed. But with the assignment operator, I have already a living object, living valid object. So I have to delete sometimes my memory allocation, my allocated memory. Good. So shallow and deep copies, important concept again. We'll talk about this maybe more. There was an example from the book that talks about the assignment operator for a simple string class. I think I found some simple string class, and I'm going to show you in a few minutes. We talked about this pointer. I mean, this is just a minute. This is a point. Okay, what is the type of this? At the beginning of each function, member function, I have this. Okay, pfRAD pointer this, but this is a constant. Okay. There is a definition like this. Okay. This is a pointer to PF array D, but this is a constant. I mean, I hate this name this, but I keep saying this is this. But you know what I mean by this, right? So this is a constant pointer. You cannot change its value. But over this pointer, you can do whatever you want. You could say things like this and this and row, for example, used. Okay, no problem. Usually we use this to do stuff like this one, line 77. I am returning a reference to myself. Whenever you talk about yourself, that's how you do it. This, okay? You talk about yourself in case you need to talk about yourself. Sometimes this is used in weird situations like, I don't know, it doesn't happen. It would be a very stupid thing, but I mean, we keep doing stupid things. Why should it matter if I do one more? Let's say this is used. So for some reason, my parameter name is used, but used is also my data member, right? So how am I gonna differentiate between this used and this used, right? So in that kind of cases, I can say this used, this one is the same as, these two are the same, okay? This one is my data member used. Okay, this one is my data member used. So sometimes I do this just to differentiate between your parameter and the data member, but don't do this, okay? Usually with this, I just return a reference to myself or do that kind of stuff that I need to talk about myself. And most of the time you think you can get away with with not using this keyword this most of the time, but in this kind of cases, yeah, you really need to. Maybe I can do this. Maybe I just return right side, right? Well, why don't I do that? If I do this, of course, this would be a constant in that case. Did the same thing again? Okay, constant. So, kind of got away from it, but I had to make this constant change and etc. Try avoid using this because there are better ways of achieving stuff most of the time. Okay, yes.
I know myself why I am returning something in overloaded operator assignment.
You mean this?
Yes.
Because right side is the same as myself now. It's an assignment operator.
It's member function. I know myself why I am returning this.
No, well, I'm not saying that you should return a reference to somebody else. I'm saying that most of the time there is a solution for not using this, okay? In the previous example I said that remember that parameter used, the name used. Don't use such a parameter name so that you don't have to use this, okay? But sometimes you cannot avoid it. You have to use this keyword, okay? Keyword this. And this was just one stupid example that I just created to avoid using this keyword, okay? But I'm not saying that do this, okay? This is a better way of writing stuff. Okay, return this one. Okay, so we talked about this keyword. What else? Yeah, I think that was the beginning of it. So any questions so far? Let me go back and try to locate chapter 10. You have these codes, right? The sample code from the book. It is available somewhere. on the book site or whatever it is. Yeah, simple string. Maybe here it is. Chapter 11 version. What is this? PFRAD. Yeah, well, this is different. No, don't do that. Okay, let me try to open the simple string CPP and project CPP. I don't like these implementations, but I mean, it will let me talk about what they are doing correct and what they are doing wrong. So let's look at this simple string header, or maybe let's look at this project CPP. Okay, project CPP, it just includes this simple string H. Okay, and my string, the class name is my string S. Okay, it is doing this nice initialization. My string T is just, okay, that one. Then my string W, and I say enter string, and obviously stream extraction works and stream insertion works, and combination with the other stuff, S, S, T. I hate this. Why? Just put a space in between. These are words, right? You put space between the words. Okay, much readable. So it looks like operator plus is implemented as a catenation operator. Operator equal to is implemented. What else? Comparison is implemented. And they are using the string copy from the C library. So look at this one. It says that copy, okay, buffer is just a character array of 255. It says that just call this function cstring on this string S. So I think it will return you a character pointer. Now you can copy the contents of my string into this classical C string. Okay, what else? Get line works, and what is this? Okay, buff plus T. What is T? Yeah, so this one will work. The type of buff is who is talking? Somebody's talking. Is this? Do you guys see who's talking? I need to turn that off. Somebody's microphone is on. Please turn your microphone off. Yeah, okay, I found it. Okay, good. So see, this one says that buff plus T. Buff is just a character pointer, and T is my string. Okay, so plus operator is going to work, but it looks like this plus operator is a global overload of the plus, and I think this will return just a sample and object of my string. Okay, I guess that's it. That's the implementation. It didn't use anything about, I guess, the index operator, but I think it is available. Less than, greater than, it didn't use, but equal to, not equal to is there. Let's look at the header actually. Here is my header. Okay, so my string, okay, says that it takes a character pointer, and default argument is null pointer. If you don't provide anything, so there is a no parameter constructor, right? No parameter constructor, of course, doesn't take anything. It just initializes this x to null pointer. That's nice. Big 3 is needed because this class is a dynamic class. This plus operator and etc. is going to work. And let's look at this one. It says, okay, I'm going to keep my data as a character pointer, and I'm going to keep my length as length. Okay. So this one keeps the length of the data and the character pointer. I am not sure if it's going to use a null terminated strings or not. Probably it will, because it will get lots of help from the C string library. Okay, so since I have this pointer, I need to use this big 3, and I am defining the big 3. Okay, I get a constant my string reference and destructor and the assignment operator. Okay, these are all fine. Okay, I mean, you just type these 3 lines one after the other if big 3 is needed. All you need to do is just change the class name, that's it. Equality operator not equal to operator. This concatenation stuff takes another string, okay, and it looks like it adds it to this string. This one returns a constant character pointer. I think this one is not a very likable function because it is exposing its internal data, the private data, to the outside world. But surprise, this same thing is available for the standard C++ string too. Luckily, this one doesn't make it a non-const. It's a const character pointer, so you cannot change that character string inside this class, but it is still exposing the internal data. But as the length is a constant function, read line, read and write, these are all functions that will, are these, okay, read to end of line, read to white space, and there's a constant or stream. So these will be used for writing, reading from the streams, input streams or output streams, and etc. So let's look at the implementations one by one. By the way, this plus operator, stream insertion and extraction are implemented as a global functions because I have to implement these two as global functions. Okay, are they friends? They are not friends. That's nice. Okay, they are not friends. Good. So global function, and this one is implemented as a, okay, I have to implement these two as a global function. This one is implemented as a global function because what? Because if I do that, let me go to this one. If I do that, this would be possible. Remember, buff is a character pointer, T is my string. So this will work. Why? Because there is a conversion constructor that converts from a character pointer to my string. So the compiler will call that conversion constructor to convert from that character pointer to my string, and there is this operator available already, so this will work. Remember the reasons, one of the reasons why we were using the global operator overloads. This was the case, and they are using it. Okay, and they forgot about the index operator, but it's a simple thing to do. Character reference operator index, and it will take an integer I, right? And for this one is not an unconst, it will just let me implement it here. Just return data. This is a convention some people use. Yeah, return data I. They say that all of my data members will start with the underscore, okay, underscore character, so that whenever I read these functions, whenever I see that starts with an underscore character, I know that it's my data, okay. So the functions are regular function names, but the data is named like that. Okay, so it's just a convention. And if you like to use this one, it is accepted. Everybody knows this. I suggest you declare your variables like this. So just simple index operator, and of course I need to overload this with a const so that it works on the constant strings too. Let's look at the implementation. Simple string implementation, including the header. Okay, this is my constructor. I have a single constructor. Sorry, I have a constructor that takes a character pointer and a copy constructor, of course. I don't like this line. It should be null PTR, right? Okay. If X is not a null PTR, then get the length of the string from the str length function. Allocate some new data. What is +1? +1 is, I guess, for the null space, okay, null character, and run this string copy. Otherwise, don't do this. Null PTR, and length is 0. Okay, so this is my constructor. So it behaves like a one parameter constructor and no parameter constructor. Question for you: should I do? Remember what did I say? Whenever you have a constructor that takes a single parameter, always think about putting an explicit keyword at the beginning. Should I put an explicit at the beginning or not? Yeah.
It converts null to null PTR, I guess. So we don't should.
It doesn't convert null. It converts a character pointer.
If I use with no parameter with this constructor, it should do something.
Yeah.
And
So should I put an explicit at the beginning or not?
no, you should not.
Well, the answer is correct. I mean, yeah, we should not, but I was expecting a different answer. Why we shouldn't put an explicit at the beginning? If I put an explicit here, then this line will fail, line 36, right? Because buff is a character pointer. Compiler doesn't have any way to convert a character pointer to a string, my string, and this line will fail. Is that what you were saying?
Similar.
Kind of?
Similar.
Yeah. Okay. Why are you looking at me like that? I mean, this is the 5th time I'm talking about this. Is that the reason you are bored? Yeah, we know this. Yeah, you told us that. I hope that's the reason. Okay, so don't put explicit here. Explicit would be bad, but it would be a good thing for the PFRAD. Okay, implementation again. This is that one. If it is null pointer, then just do this like 0. And my string, okay, copy constructor. If the other string's length is greater than 0, then get the length. Okay, allocate this much space and do the string copy. So I am just using the C string library as a workhorse. It is doing all the stuff, detailed stuff for me, just copying things around and etc. And again, the same thing. Why don't I do this? Why don't I? Control H doesn't work. Search and replace. Where is search and replace?
Control F.
Control F? Really? Control F is just finding stuff.
It also replaces.
Find, replace, yeah. So find all the nulls and replace them with null pointers. So it's not going to ask me anything? Oh God, did you see that? That's stupid thing, okay, case sensitive. So it did it Control Z, okay, good. So Control F, replace, change all the nulls to null pointers. How about this one? What is this? Backward, forward. Okay, replace. Backward. Okay, good. So let's go back. This is my copy constructor. If length is greater than 0, then do this and do the copying, otherwise do that, okay? And in this case, what if my data is not null? Because in this case, if the string doesn't contain anything, I just construct the string without initializing it, my data doesn't point to anything. But in that case, if I delete something that doesn't point to anything, that would be a bad thing. So if my data is not null pointer, then delete it, okay? An assignment operator is usual if length is greater than 0. If my length is greater than 0, what does that do? It says get the length from the other one and make a temporary character pointer of this size and use strcat. Okay, why is it using the strcat? What is up with the strcat? That's a bad thing. I mean, you know the problem with the strcat here?
It should not be string copy.
Well, I mean, this one assumes that the first character, the character number 0, would be a null character, right? With the strcat. What does the strcat do? It finds the end of the string and it catenates the other one to this one. That would be a bad thing, actually. So this is not strcat, this is strcopy. Okay, so I'm going to copy the data to this temp, and if I have the data, and I will just delete the data, and my data is temp now. Okay. By the way, I don't have to check if the data is not null, because if it is null, then my length would have been 0, right? So this line is not necessary. What is? Okay, just delete it that way. Okay, so if length is 0, okay, length is 0 already. I don't know what this is talking about. If length is 0, then don't delete the data. Data is null pointer. Maybe it is talking about, maybe it is something like this. It is talking about some deleting characters from the end of the string. Even though you have some space, you end up pointing to 0 characters, maybe like that. But this is not good. So if length is 0, then length is 0, don't do anything. Oh, okay. If length is 0, isn't this assignment operator? Oh, okay. This one is, sorry. This is all messed up. Okay, good. This one is talking about the length of the x. If x length is greater than 0, then do all these. If the length of x is 0, then my length is going to be 0. If I am pointing to some data, then delete my data, and my data will be null pointer, and return this one. Okay. So that's what it is doing. But there is a problem with this code. You know what is the problem with this code? I think it's a bad problem. It is this. If somebody writes something like this in the code, my string S1 1 2 whatever, okay, and then they did this. It assigns itself to itself, okay, S1 to S1. I can write something like that, right? I mean, I am not crazy, but I write it by mistake, or sometimes the algorithm is this kind of stuff. So this X is same as this. Okay. So what am I going to do now? I get this. It says that if my length is greater than 0, I am going to assign my length to my length again. I am going to make a new space of length plus 1, and I am going to copy my data to that new space, and I am going to delete my data, old data, and my new data will be. So what am I doing here? I am all just without, I am just repeating myself. I am just copying myself to some new place. I am doing lots of unnecessary stuff, right? Is that correct? And I don't deal with this part. So this is only a bad thing because I am doing some unnecessary stuff. That's what I am doing, right?
But still it works.
What?
Still it works. Yes, we are using unnecessary memory.
Well, it doesn't memory leak. Everything is fine with this one.
We are delete old copy and create new copy.
Yeah.
Unnecessary.
So no problem. We are not causing any dangling references. We are not causing any. Memory leaks, right? It just we are doing something unnecessary. Okay. In this case, it turns out that way. But sometimes it causes serious. This one checks this length is greater than 0. That's why I guess it is the thing. Sometimes, okay, copy it and delete it. Delete my data, X data. Okay. Some people do this, okay, at the beginning. If I do that, what would be the problem for the usual case? If I have data, I just delete my data, right? If I have data, I just delete my data, then I set my length, and then I get a new temp, and I copy the other's data to my temp, and my new data would be this. Or in fact, sometimes I can do this too without using a temporary. Okay. So much shorter. Okay. If I have data, I am just going to delete it. I get the length from the other one. I get the character array, new character array to my data, and I copy others' data to my data. Okay. So this should work fine unless I write something like this, right? If I do this, I deleted my data, and I am trying to copy my data to my data, that will be a problem. Okay, either don't write it like this, but I like this code. Why I like this code? I don't have to use the temporary variable. One thing. The other thing is that I deleted my data first and I'm getting a new one. So I am not using too much memory now, because why do I keep my old data? Because I am going to delete it anyway. So what am I going to do? Usually people do this. If this x, okay, if this x is the same as my address, then I just don't do anything, return this. Okay. If the address of this object is the same as my address, that means that somebody is running something like this, right? So don't make any copies. Just return myself, I am done. So usually the first line of your assignment operator, if you are overloading it, should be this. Check for self-assignment. Check for self-assignment. Okay. Any questions?
Marcus,
Yeah.
I shouldn't, in the first statement. If
You mean
this,
the 45?
Yes. Shouldn't it be this forwarder of x? Wouldn't it?
This
Yeah.
arrow x,
Yes.
I don't have a data member named x inside this string. X is my parameter to the assignment operator. No. I am comparing myself with the address. I am comparing, I mean, what is it? This is my address, right? This is my address, right? So I am comparing my address with the address of the object that is being passed. Okay.
Okay.
So if they are, I mean, don't confuse this with this one. I am not saying that. Okay, let me write this. I am not saying this. I am not saying that compare myself with this new object. I am not trying to check my contents, okay? I am saying that if my address is the same as the address of this object, then this is a self-assignment. Then don't do the self-assignment, just return. Okay? So the original code didn't have any bugs, but the original code had to use more memory. Why? Because it had to use the old data and it had to keep the temporary data together in the memory. But I am going to delete the old data anyway. Why am I going to keep it in my memory? So at the beginning I am just deleting it, then I am getting all these. But for that as well, I have to make sure that the past object is not my object. Okay, so this one is really just calls the strcmp with the data, okay, data and s data. Just call strcmp and that's it. Not equal to, just call the strcmp. Remember, strcmp returns minus, plus, and 0, 3 things. It just compares stuff, remember. If it returns 0, that means that these two strings are equal. Plus assignment operator, okay. First, I am going to do this. I am going to add the length of the other string to my length. And there is a new data, okay. I'm going to keep a pointer to my old data. And my new data will be, okay, length plus 1. Remember, I updated length already. My length is the total length of these strings. New character, so I am going to copy this temp to data, and string cat is going to catenate at the end of my string, and I am going to delete this temp because this temp is pointing to my old data. Would there be a problem with this self plus assignment? I don't think that there will be a problem, right? Because I am keeping the old one, and I'm just copying it, and it will work. Okay? Good. Oh, I am way out of my time, but the rest of them are like that they are not very difficult. They are talking about reading and writing and etc. Oh, this one is good. Okay, let's look at the implementation of this one. Let's call it a day today. Operator plus, remember global operator S1 and S2. S1 is assigned. Okay. By the way, this is not an assignment operator. This one. This one calls the copy constructor directly. If you are making a new object like my string C, assignment operator or equal sign, and S1, this one will call the copy constructor of my string. Okay? That's the C way of running stuff. This will call not the assignment operator, but the copy constructor. This is an initialization thing. Okay? So this is way different than writing this and this. Okay, so these two lines are, well, they end up with the same C, but this one will just call the copy constructor and it is done. This one will call the default no parameter constructor and we'll call the assignment. So two things are happening here. Okay, two things are happening with these two lines, with these two lines, but only a single thing is happening with this line 45. So whenever possible, use a syntax like that to initialize your objects. This is not an assignment of it, this is an initialization. Okay, so get rid of this one. So, and it says that I am going to call this nice C plus assignments S2 statement. Plus assignment is already implemented, so this should work very well. I am just using my other functions for the plus operator. Okay, that's it. I don't like how you look at my slides. I don't like how you are looking at me. I don't know what you are doing with your mouth and nose, but your eyes doesn't look like you are understanding anything. Do you understand really anything? I am just looking at like the seeds, not yourself. Türkçe söyleyin, anlamıyor musunuz ya? Vallahi kızıyorum ha. Anlıyoruz deyin. Yalan söyleyin. Yalan söyleyin. Nasıl da ne yalan söyle, ne diyor? Yalan söylüyorsun. Yalan söyleyin ya. Deli hocam ben burada ya. Sorunuz yok mu hiç? Kimse bir şey sormaz ya. Senin hakkında konuşmuyorum burada. Onu da küstürdük. Tamam, sor.
O zaman İngilizce soracağım. Wouldn't it be more apparent?
Yok, Türkçe soracaksın.
Türkçe mi sorayım?
Ha.
Hocam şu C'de mesela parantez içerisine espri yazsaydık hani copy constructor'ın çağrılığı daha belli olmaz mıydı mesela? Şey yaparken, initialization yaparken.
Tabii ya, böyle yap tabii ki ya.
Daha belli olsun yani.
Evet ya böyle yap tabii ki, bunu daha güzel olur ama öbürü de copy constructor çağırıyor.
Tamam.
Hocam direkt S1 artı S2'yi returnlesek hiçbir şey var.
Efendim?
Çalışır mı? S1 artı S2'yi direkt returnlesek.
Ha, şuraya mı diyorsun?
Aynen.
Ha, C artı S2 öyle mi? Çok güzel.
Direkt C'yi tamamen kopyası.
Ha, böyle mi? Bunu mu return edelim? İyi de bu operatör zaten bu operatör. Recursion gibi bu.
C'yi oluşturmaya gerek yok.
Infinite recursion'a girersin. Başka? Ya eskiden de soru sormazlardı ama en azından kendi aralarında konuşurlardı ya. Anlamıyorum ki ya. Neyse tamam, ben bir sizin %80'inizi bırakayım da belki bir etkisi olur. Tamam. O bunların hepsini kaydetmişiz. Tüh. Bu son şey. Tamam olsun, ben bu kayıtta söylüyorum. Ben sizin bir %80'inizi bir bırakayım, belki o zaman soru sormaya başlarsınız. Bırakmama gerek kalmayacak zaten, kalacaksınız.
Ben soruyorum, beni bırakmayın.
Kim soruyor? Vallahi kuru yaş biliyorsun değil mi sen? Hiçbirinizi tanımıyorum ki. Hepiniz maskeyle geliyorsunuz. Nedense hiçbirinizi tanımıyorum ben. Yüzünde maske vardı, hatırlamıyorum.